You probably know about crossword puzzles for brain health. But what if sniffing 4 distinct essential oils before breakfast does more to rebuild your hippocampus? It's a strange medical phenomenon called olfactory neurogenesis, and it's reversing age-related memory loss. That single finding, published in July 2023, launched a worldwide conversation about whether something as plain as smelling essential oils could shield the aging brain from cognitive decline. And today we are going to examine exactly what the science says, what it does not say, and what you can do at home for less than $30. Before we get into the study itself, we need to talk about something unusual in the way your brain is wired. Because the connection between your nose and your memory has no parallel anywhere else in the human body. Every sense you possess, whether sight, hearing, touch, or taste, routes its signals through a relay station called the thalamus before those signals ever reach the areas responsible for memory and emotion. Smell skips that step entirely. Odor molecules first bind to receptors in the olfactory epithelium, the specialized sensory tissue lining the upper part of your nasal cavity, and that signal travels straight through the olfactory bulb into the piriform cortex, the entorhinal cortex, the hippocampus, and the amygdala, which together form the core of your brain's memory circuitry. No detour, no relay, a direct line. UC Irvine neuroscientist Michael Yassa described it this way. The olfactory sense holds the special privilege of being directly connected to the brain's memory circuits. And everyone has experienced how powerful aromas are in evoking recollections, even from very long ago. Psychologists call this the Proust effect, or Proustian memory, named after the novelist Marcel Proust, who famously described how a single scent could unlock a cascade of vivid autobiographical memories. A whiff of cinnamon that transports you to your grandmother's kitchen, or pine needles that drop you right back into a childhood holiday, those experiences are not poetic exaggeration. Your nose feeds straight into the part of the brain that stores memories, and no other sense can match that. A second reason the olfactory system stands out runs even deeper. In mammals, only 2 brain regions receive a steady supply of newly born neurons throughout adult life. One is the hippocampal dentate gyrus, central to memory formation, and the other is the olfactory bulb, the very structure that processes smell. Rodent studies show thousands of new interneurons arriving in the olfactory bulb every day, and exposure to diverse, stimulating scents increases the survival of those cells. Olfactory deprivation does the opposite and kills them off. But here is where the story gets more complicated for humans. Evidence for adult neurogenesis in the human olfactory bulb remains contested. Curtis found supportive evidence in 2007, while Sinai in 2011 and Bergman in 2012 found rates far lower than in rodents. The honest scientific language, and the language I will use throughout this video, is that smell training stimulates neuroplasticity and helps maintain brain circuits. Claiming it definitively grows new brain cells in human adults goes further than the current data supports. What is far clearer, and what should genuinely concern anyone past 60, is the relationship between smell loss and cognitive decline, because multiple large studies spanning thousands of participants now reinforce that connection. A landmark 2015 paper in the journal Neurology by Devon and colleagues tracked 1,037 non-demented older adults in New York City and found that scores on a standardized smell identification test outperformed verbal memory tests at predicting who would eventually develop Alzheimer's disease. A 2018 analysis of the National Social Life, Health, and Aging Project put the risk in sharper terms. Older adults with olfactory dysfunction carried roughly double the odds of receiving a dementia diagnosis 5 years later. Researchers have also noted that carriers of the APOE4 gene, the most significant genetic risk factor for late-onset Alzheimer's disease, tend to show earlier and more severe olfactory deficits, suggesting the smell-cognition link may be especially meaningful for people with that genetic profile. Meta-analyses deepen the pattern, with a 2017 review of 31 studies documenting a moderate to large smell deficit in people with mild cognitive impairment, and a 2018 review showing an even larger deficit in diagnosed Alzheimer's patients. Smell loss follows a very specific pattern inside the brain, and that pattern tells us something alarming. Neurofibrillary tangles, one of the hallmark signs of Alzheimer's disease, show up in the olfactory bulb and the entorhinal cortex before they appear anywhere else. Brock and Brock documented that back in 1997. Your sense of smell may be one of the very first things the disease process attacks, potentially years before you notice any changes in your memory. And that leads to what might be the most underreported health statistic for this age group. Most older adults losing their sense of smell have absolutely no idea it is happening. A 2002 study published in the Journal of the American Medical Association mapped the age curve for smell loss across the United States. 6% of adults ages 53 to 59 showed measurable impairment. That number climbed to roughly 13% between 60 and 69, hit 29% at ages 70 to 79, and reached a striking 62.5% among those over 80. Clinicians have a specific term for this age-related smell loss, presbyosmia. It is an actual ICD-coded medical condition, the same way presbyopia describes age-related vision loss, and yet most physicians never screen for it. The National Institute on Deafness and Other Communication Disorders estimates that 13.3 million Americans over the age of 40 carry measurable smell dysfunction. University of Pennsylvania researcher Richard Doty, who developed the widely used UPSIT smell identification test, has written that roughly half of Americans between 65 and 80 and 3/4 of those over 80 have demonstrable smell loss. The hidden problem is staggering. A 2022 analysis of more than 41,000 women in JAMA otolaryngology found that self-reporting caught only 22.6% of objectively confirmed poor olfaction. KFF Health News put it bluntly. Up to 75% of older adults with some smell loss are completely unaware. You may already be losing this sense without knowing it, which means you may be missing one of the earliest available warning signs of changes in brain health. That warning sign carries weight far beyond cognition. A 2014 study by Pinto and colleagues found that complete smell loss predicted roughly 3 to 4 times higher 5-year mortality in older adults, with an adjusted odds ratio of 3.37. That association turned out to be stronger than heart failure or cancer in the same group of participants. Smell functions as an unusually sensitive canary for overall health. All of this background explains why researchers began asking a very different question. If smell loss signals decline, could training the sense of smell work in the opposite direction, slowing the damage or even reversing some of its effects? The formal scientific practice of olfactory training traces back to a German researcher named Thomas Hummel at the Technische Universität Dresden. His 2009 study in the journal Laryngoscope introduced a structured protocol for patients who had lost their smell to viruses, head trauma, or unknown causes. The condition caused by viral infection, which became widely recognized during COVID-19, is formally called post-viral olfactory dysfunction. The method Hummel proposed was deceptively simple. Patients sniffed 4 specific essential oils twice daily for 12 weeks. Each of those 4 scents represented a different category from Henning's odor prism, a classification system originally published in 1916. Rose covered the flowery category, lemon covered fruity, clove covered spicy, and eucalyptus covered resinous. Spanning those 4 categories engage different types of olfactory receptors and different processing pathways in the brain. Hummel's group also developed the Sniff and Sticks test, a standardized clinical tool using felt-tip pens infused with specific odorants, which has become one of the primary research instruments for measuring olfactory function in clinical trials worldwide. 2 minutes is all it takes. You open a small jar, hold it roughly an inch below your nose, inhale gently for 10 to 20 seconds, concentrate on the scent, and actively visualize what you are smelling. Then you pause briefly and move to the next jar, repeating the process for all 4. Morning and evening for at least 12 weeks, with longer delivering better outcomes. The evidence base behind this routine is anything but thin. A 2017 meta-analysis of 13 studies in the journal Rhinology found large effects on both odor identification and odor discrimination. A comprehensive 2022 review by Peniak and Hummel, covering 13 years of accumulated research, concluded that roughly 30 to 70% of patients with post-viral smell loss achieved clinically meaningful recovery after 3 or more months of training, compared to only 5 to 35% without any intervention at all. Smell training became the default first-line therapy for post-COVID smell loss across the globe, and brain imaging data helps explain why. 12 weeks of training produced increased gray matter volume in the hippocampus, thalamus, and cerebellum of patients with reduced smell. Healthy young adults who completed the same training showed increased cortical thickness in the entorhinal cortex and the fusiform gyrus. The training physically altered brain structures tied to memory and sensory processing. A modified protocol developed by Altundag in 2015 pushes the concept further by rotating to a new set of 4 scents, every 12 weeks over 36 total weeks. That first set uses the classic Hummel 4, the second adds menthol, thyme, tangerine, and jasmine, and the third introduces green tea, bergamot, rosemary, and gardenia. Head-to-head comparisons show the rotating version outperforms the original. Which brings us to the study that generated international headlines and that you have most likely already encountered. In August 2023, UC Irvine's press office released a story headlined, "Itchy's Sweet Smell of Success. Simple Fragrance Method Produces Major Memory Boost." The number 226% appeared everywhere from Science Daily to Yahoo News, and the reaction was enormous. Let me walk you through exactly what the researchers did and found because the details reshape the picture entirely. Cynthia Wu and Michael Leon led the study at UC Irvine, with Michael Yasa contributing brain imaging expertise. Publication landed on July 24, 2023 in the journal Frontiers in Neuroscience. Participants were community-dwelling adults between 60 and 85, all cognitively normal with mini-mental state examination scores of 24 or above, randomly assigned to either an enrichment group or a control group. Each person in the enrichment group received a bedside diffuser that released one essential oil for 2 hours as they fell asleep, rotating through 7 oils across the week: rose, orange, eucalyptus, lemon, peppermint, rosemary, and lavender. Control participants received the same device, but their bottles contained distilled water with only an undetectable trace of odorant. The protocol ran for 6 months. Originally, 132 people enrolled. COVID-19 disrupted the trial badly. Final analyzed groups shrank to 43 total for the brain imaging component and only 23 total for the cognitive testing, with 12 in the enriched group and 11 controls. On the Ray Auditory Verbal Learning Test, a standard neuropsychological assessment, where participants try to memorize a list of 15 words over 5 attempts, the enriched group gained an average of 0.92 additional words on the 5th trial, while the control group lost an average of 0.73 words. The statistical interaction reached significance with a large effect size, and that ratio between those two small changes is where the 226% number comes from, less than one additional word on a 15-word list. The enriched group remembered better, the controls remembered worse, and the math between those shifts produced the headline. Other cognitive tests in the study, including the mini mental state examination, digit span, and letter number sequencing, showed no differences between the groups. Brain imaging did reveal something notable. Participants in the enrichment group showed a change in the left uncinate fasciculus, a white matter tract connecting the amygdala and entorhinal region to the prefrontal cortex. That tract typically deteriorates with aging and in Alzheimer's disease. The authors interpreted this as preserved or restored white matter integrity. But here's the catch. The brain change did not statistically correlate with the memory change in the small subgroup that had both measurements. The study authors acknowledged their own limitations directly, writing that they included the small sample size and the single odorant that could be diffused each night. 2 other facts belong in this picture. Procter & Gamble funded the research, and both Leon and Yasa disclosed travel and speaker compensation from the company. Claims that the enriched group slept more soundly, which appeared in many news summaries, were not statistically supported in the paper itself, as the 22-minute sleep increase fell short of significance. First author Cynthia Wu captured the practical appeal when she noted that by making it possible for people to experience the odors while sleeping, they eliminated the need to set aside time for this during waking hours every day. For an aging population struggling with daily routines, that convenience angle carries genuine weight. Since that 2023 publication, several other research groups have tested olfactory training, and the results paint a mixed picture. A 2021 study from Hummel's group in Dresden ran 68 adults aged 50 to 88 through 3 or 6 months of twice-daily training. Scores on a dementia screening test worsened in the control group but held steady in the trained groups, and MOCA scores improved in one training arm. Separate work found improved verbal fluency and short-term memory in older adults after training. A 2014 study showed training could prevent age-related olfactory decline altogether. The most balanced synthesis comes from Vance and colleagues, who published a 2024 systematic review in the journal Neuropsychology Review. Their verdict on the cognitive evidence used one word: emerging. They found the research suggestive for improvements in verbal fluency, verbal learning, and global cognition, but limited by small sample sizes, inconsistent blinding, and short follow-up periods. A 2025 systematic review in the Ear, Nose, and Throat Journal applied harsher scrutiny, rating 7 of 12 randomized controlled trials at high risk of bias, and 11 of 12 non-randomized studies at serious risk of bias. A 2025 trial found that cross-modal transfer from olfactory to visual memory fell short of expectations. Expert opinions split sharply along the spectrum. Richard Doty at the University of Pennsylvania offered this assessment: smell therapy could have some minute effect, but studies have been so poor. J. Piccirillo, editor of JAMA Otolaryngology, stated that the theory of neuroplasticity is well accepted, but with regards to its application as olfactory training, the jury is out. Duke's Bradley Goldstein noted that it is generally not considered harmful and that he has recommended it with somewhat tempered expectations. Hummel himself remains careful, noting that in some cases the improvement can be 25% and in others it reaches more like 70%, and that people with post-infection smell loss for a short period of time carry a higher likelihood of recovery than those who had smell loss for 2 years. Michael Leon stands at the opposite end. His words were blunt. This is the most effective treatment for dementia and Alzheimer's disease by a mile, and nothing else comes close. That claim is promotional in nature. It refers partly to a separate study, not a head-to-head comparison with approved medications, and it extends well beyond what the published evidence supports. Leon has since launched a consumer product called Memory Air, a device priced at $799 plus $39 per month for scent cartridges. No FDA clearance or approval supports any cognitive indication for this product. The company itself acknowledges that the device has not been tested to replicate the underlying study results. Before we move to the practical steps, we need to talk about safety, because essential oils carry real risks, especially for older adults. The American Lung Association warns that inhaled essential oils can irritate the respiratory tract and that these oils receive no FDA regulation for quality or purity. The Asthma and Allergy Foundation of America warns that diffused oils can trigger asthma attacks. Eucalyptus has been specifically linked to bronchial irritation. That UCI trial explicitly excluded participants with asthma, allergies, fragrance sensitivity, sleep apnea, or chronic obstructive pulmonary disease, which means the clean safety profile from the study does not automatically extend to those populations. Anyone with those conditions should consult a physician before running a diffuser. Essential oils also pose a poison risk if swallowed, with eucalyptus and peppermint carrying the greatest danger, a concern worth weighing if young grandchildren or pets share your home. So what should you take away from all of this? Here is the framework that fits the full weight of the evidence. First, pay attention to your sense of smell. Clinicians call age-related smell loss presbyosmia. If foods taste blander, or if fragrances seem weaker, bring this up with your doctor. Smell loss may be one of the earliest, cheapest, and most underused signals of brain health available, and up to 75% of older adults have no idea anything has changed. If you have a known APOE for genetic risk factor for Alzheimer's, this conversation with your doctor becomes even more important. Second, if you want to try olfactory training at home, start with the Hummel protocol. Pick up 4 essential oils: rose, lemon, clove, and eucalyptus. Place a few drops in small jars. Hold each one about an inch below your nose, and inhale gently for 10 to 20 seconds while focusing on the scent and visualizing it. Morning and evening for 12 weeks. This approach carries the strongest evidence base, especially for maintaining or recovering your sense of smell, and brain imaging research confirms it produces measurable changes. Third, if you want to try the overnight enrichment approach, a simple bedside diffuser with 7 essential oils will replicate the UCI study protocol. Rotate 1 scent per night each week. Keep in mind that the 226% finding has not been independently replicated and emerged from a cognitive analysis of just 23 people. Fourth, treat any $799 device claiming to prevent dementia with the same healthy skepticism you would apply to a supplement making similar promises. New trials are recruiting, including one at Peking University Third Hospital, but independent replication remains the single most important thing. The National Institute on Aging has not funded a major clinical trial. The most valuable insight from the last 3 years of research has nothing to do with aromatherapy products. It is that the decline of smell may be one of the most sensitive indicators of brain health we have. A few dollars of essential oils, 2 minutes twice a day, and a conversation with your doctor about presbyosmia costs almost nothing and carries minimal risk for most people. Whether the memory benefit turns out to match that figure or lands at something far more modest, the routine itself puts you in position to catch a warning sign that 3/4 of older adults are missing entirely. If you found this useful, share it with someone you care about, and subscribe to the channel for more evidence-based health content for adults over 60. As always, speak with your physician first. Thank you for watching this evidence-based health documentary.